if you look at you don't have to refer to your booklet, but this is the second stop. And this project we call Climate Smart. Basically what the intention was kind of like a myth buster. We knew that certain things don't necessarily work in Florida, but we decided to design a study to prove that. So essentially what we're trying to do here is we have a Bahia grass pasture. We know the Bahia grass pasture sequester a lot of carbon. So what are the management options that we can impose to improve that ability of Bahia grass pastures to sequester even more carbon and hopefully enhance soil health and reduce greenhouse gas emissions? So that was the entire purpose of the project. By the way, forgot to introduce, this is Julian Avila. He's the master's degree student that's been working on this project. This is a relatively new project. We started about 2 years ago and we're about to end. And this is the topic of Julian's master's degree dissertation. But essentially, if you look at the booklet, we have about 7 treatments. So things that, for instance, NRCS is paying cost share. So if you overseed legumes, what happens? Does it improve the soil health? Doesn't matter if it's an annual legume versus a perennial legume. How about if we manage the soil fertility? If we apply nitrogen, we know nitrogen promotes forage growth. How that translates in terms of soil responses. So these are the type of treatments that we have. Like I said, initially we have a total of 7 treatments. One of them included overseeding native species. There's this, in other parts of the country, there's this general consensus that once you replace cultivated grass like Bahia grass is not originally from Florida, it came from South America. When you replace with Bahia grass or cultivated species with native species, there are some benefits. So the issue with that, and we knew that we were going to encounter a lot of problems in the way. So that was exactly the purpose of this project. Are those management options effective? Can we actually use that in Florida? When you look at, we interact with consultants, carbon credit companies, they think all those things work wonderfully in Florida. So the reality is a lot of those things may work in other places, but are very difficult to be implemented in Florida. So it was kind of hard to convince a grad student that we're set for failure. But in the same time, we want to document not only the success, but also things that may not necessarily be as easy as a lot of people assume to be. So the treatment, there's not much, by the way. I know we brought you here. In terms of visual, they all look the same. You see the size of the plots. And we measure forage production. We measure greenhouse gas emissions. So if you see a metal frame, that's where Julian comes every other week. He closes that frame and collects gas, and it takes the gas sample to the lab. In the lab, he analyzes how much carbon dioxide, nitrous oxide, and methane is in that sample. So he does that throughout the year to quantify how much. We know the pastures, they emit carbon, they emit methane. Not only the cows emit methane, but also the soil emits quite a bit of methane, especially when it's wet. But we also know that pastures are very effective at sequestering carbon. How they do that? The plants, when they do photosynthesis, they convert energy from the sun into carbon, and part of the carbon that's in the plant material becomes part of the soil organic matter. That's how soil carbon sequestration occurs. So we want to know are there any ways that we can improve Bahia grass carbon sequestration potential by manipulating fertility, by overseeding legumes, or reintroducing native species. A couple additional treatments that we added after the project started had to do with soil amendments. So some of you may heard about biochar. Has anybody heard about biochar? Yeah, it's some of the indigenous people in South America use in the Amazon probably heard something about tierra preta. And that's where the indigenous people use the ashes to improve the soil fertility conditions so they could grow crops. So biochar has received a lot of attention in the scientific community. and a lot of claims in terms of boosting production, boosting soil health, increasing soil carbon, water retention capacity. This is all claims. We want to know, does it really happen? And if it does, to what extent biochar can help. So I have some limited, like I said, we started this 2 years ago, so the data is still preliminary. We need at least 2 years of data to make more meaningful conclusions, but the reality was that none of the things that we tested here, right, Julian, really worked. The only thing that actually, so Julian comes here, I mentioned he comes here every other week to measure gas. Biochar is supposed to reduce carbon dioxide emissions. Did it happen? No. So from the agronomic, we're focused on both. It needs to be something that improves some of these environmental responses, but it also needs to boost forage production, because there's a cost associated with these amendments or these management techniques. That's where Hannah Baker is going to help us figure out. Thankfully, Hannah, your work is going to be relatively easy because nothing really worked. So why spend the money into something that you are not, really is not producing any agronomic or environmental benefit? So the bottom line, everything that we've been measuring here for the past 2 years, only differences. And remind me if, yeah, the cows are pretty excited about our presence here. Yeah, they're like, we're not the methane emitters. Correct me if I'm wrong, but so we had one of the treatments was adding nitrogen. I mentioned nitrogen promotes. Would it be okay if I leave like this?
Yes.
Okay, that's much better. No, but now it's not working, right?
Yeah, you got.
It is working?
You have to speak into.
Okay,
yeah.
very cool. Nitrogen, when we apply, why we apply nitrogen to our pastures? Because we want to improve production, maybe also improve nutritive value, protein and digestibility. So you improve above ground biomass, but you also improve roots. Those roots eventually will decompose in the soil and will become part of the organic matter. So by applying a lot of nitrogen, can I accelerate the process, put more roots into the ground, and maybe increase the soil organic matter levels? Maybe. The answer for that is maybe. What we've seen here in the short term, 2 years, with a lot of nitrogen, 200 pounds of nitrogen per acre for 2 years, so 400 combined, no difference. So nitrogen can potentially increase carbon sequestration when the companies, like I said, the consultants come here. Well, we're going to tell producers to apply nitrogen. Yeah, maybe 10 years from now, they'll see a response. At what cost? So even at very high levels that we used, increased production, so far no differences in the soil, any of the soil properties that we measure. I mentioned carbon, but some of the other soil properties, nothing really changed over the course of those 2 years. And I want to be fair with some of the treatments. For instance, biochar, the terra preta, the ash that we add, also extremely high rates, 20 tons of biochar per acre per year. We did that twice, correct? Twice, correct. So it's, Julian loves that because it's so easy to spread, right, Julian? He looks like a coal miner after that. It's very difficult. So not only, I'm talking also, I'm not even mentioning the logistical and the practical limitations associated with those techniques. Very difficult to do in a plot scale. Imagine doing in a commercial, in a pasture. It will be even more difficult. But the bottom line with biochar, there's a lot of, if you Google biochar soil health, you're going to be bombarded by articles, not necessarily scientific articles, but a lot of marketing around biochar. The reality was that biochar, even at those very high rates, the only thing that it did increase the soil moisture level. So the soil retained more moisture. But it was during the part of the year that we don't need much moisture, correct? It was during the summer. So we had plenty of moisture in the summer. That increase in soil moisture in the summer really didn't translate into more forage. Maybe if it was in the spring or this time of the year where things are really dry, it would benefit forage. But there was, even though plots that had biochar had more moisture, that didn't translate into any agronomic benefit. So why even spend? And again, this is a 2-year study. Maybe if we continue this for many years, unfortunately, I'm not going to be here to do that, but there might be some potential benefit. But again, the main goal was to look at those short-term changes, because there's a lot of assumptions that if you do this, this is the result you're going to get. that might be true again for other parts of the state or the country where soils respond faster. We have a lot of very high decomposition rates here. So it really, all the treatments that we tested were very negligible responses other than nitrogen. And there's not much new about nitrogen. I think in the 50s, some of the researchers here told the cattle industry that, yeah, you apply nitrogen, you increase production. And that's essentially what were the results. The only positive benefit that we've seen here is the increasing forage production in response to nitrogen. And we apply two sources of nitrogen, biosolids and commercial inorganic nitrogen, and they were equally effective. In fact, statistically, if you look at the table, and you don't have to look now, but when you go home and if you want to take a look at some of the material, statistically, there was no difference between biosolids. So biosolids is the waste product from the wastewater treatment facility. The material that we apply here, Julian, I forgot. We have a biosolid sample here or no? No. Okay. So let me finish that thought, and then I'll talk about what we brought here that I forgot. Numerically, the Bahia grass production was a little bit higher when you apply biosolids versus inorganic fertilizer, ammonium nitrate. The reason for that is that when you apply biosolids, you're not applying just nitrogen. There's other macronutrients and micronutrients, and this area hasn't been fertilized, nothing. It's really poor shape in terms of soil fertility. It's very acidic. pH is around 4.5. So we want to start the project in a condition that translates where most pastures are in Florida. We didn't want to start in a place where the fertility conditions were a little bit better. But so this will be pretty good comparable situation with a commercial range. So what I forgot to mention is some of these materials. So one of the techniques that you're also gonna see if you Google anything related to soil health, soil maintenance, besides biochar, which by the way is this material here, is commercially available in Florida. You see how fine, it's very difficult to apply, but it's sold as a soil amendment in Florida. Very expensive. We buy in bulk and we apply at those very high rates, and it's surface apply, so because we also don't want to disturb the stand, the Bahia grass stand. But another technique that if you Google soil health, soil management, something like that, you're gonna come across this basaltic rock. What it essentially is, as the name implies, it's just rock that's being crushed into a certain size, particle size. So this is one of them. We have a couple different ones, also commercially available product. And it's being marketed as a way to both increase soil carbon, but also supply nutrients to the plants. So as this material is an inorganic material, so as this material weathers, so it's not decomposition, it's weathering, which may take a while for this to weather. It's supposed to slowly release nutrients to the crops, and also as part of the reaction, there's carbonates that are formed in the soil that helps with the carbon sequestration process. Like I said, this is a short-term study. So far, we haven't seen any benefits of the materials that we test. By the way, we also test two different, because there's no recommendation. Somebody asked how much biochar is recommended. There's no recommendation. So we also play with the type of basaltic rock material and the application rates, and none of them so far gave us any positive response. Anything that I forgot, Julian, that I should mention?
Yeah. Hi everyone. Maybe I can also mention that we have some soil moisture sensors here. So the idea, as Dr. Silveira was saying, was to test the effects of the treatments on soil moisture, and she talked about biochar increasing that. So I went to the field yesterday with Mike, who is also here and helped me. And we found that not taking into account also these measurements, also field measurements that we take every sampling period. So biochar increased like a couple of percentage, but it's not agronomically like feasible or significant compared to other treatments. We also have a pond water level sensor, and I was explaining to some of you guys in the poster presentation that we also found some seasonal patterns that are related to greenhouse gas emissions. So I was telling them Then last year we had very extreme rainfall events such as Hurricane Helene and Hurricane Milton that flooded these plots like we were literally walking in water here to sample our greenhouse gas fluxes, and we found okay,
You have to
Better?
talk directly into it.
like that.
Yep.
Oh yeah. So we came in September of last year, just before the hurricanes, and the plots were flooded, and it was a spike in methane emissions that was also very important to see and to report in our results. And in terms of the other two gases like carbon dioxide and nitrous oxide, we found that they were especially higher or greater within the first 2 weeks of nitrogen fertilization and also during the rainy season between June and September. And yeah, those are results that we have for the last 18 months, so from June 2024 to June 2023 to December of 2024. But yeah, it would be ideal to continue and do it in a long term, but we will see what happens.
Yeah, I just want to last comment that a lot of things in Florida are driven by weather conditions. So Julian mentioned that most of the greenhouse gas, the pulses in greenhouse gas are driven primarily because of rain, especially when we have hurricanes. That's where we see the peak. And we not in this area, but we have another experimental area that we can differentiate how much is coming from the soil, how much is coming from the animals. And usually the proportion of, especially methane, because it's such a controversial gas, the proportion that methane that comes from the soil is much greater than what is coming from the animals. But again, the soil also sequesters a lot of carbon. So we have one of the experiments that we do, we're trying to account for the balance. So considering how much is being emitted, how much is being sequestered, what is the balance? And this Bahia grass is extremely effective at sequestering. So the amount of that's being added via photosynthesis is much greater than what is being emitted back to the atmosphere. Any questions?
Did you do any groundwater monitoring for all that nitrogen you were putting on?
So the question was if we've done any groundwater monitoring because of the amount of nitrogen that we've been applying. Every year, 200 pounds is a lot. Not in this particular study, but we've done in other studies. 200 pounds, well, I think the study that we had a higher rate was close to 200, it was 180. What we find is that the Bahia grass is also very effective at utilizing the nitrogen, so nitrogen will only be lost if the plants are not able to utilize. So even in the other studies where we apply, I'm sorry, I said 180, it was 160. So the 160, if you look at the IFAS recommendation, that's the high input option for Bahia grass. At that level, we didn't see an impact of nitrogen application on nitrate or ammonia leaching. So not in this study, but in previous study, we've done that. Any other questions?
How does Bahia grass compare in terms of soil organic matter storage to other grasses around here?
So the question was how this particular grass, Bahia grass, performs in terms of carbon sequestration as compared to other species, grass species. Yeah. We never compare cultivated species against the other, but what we've done is comparing Bahia grass with native pastures. So as we drive to the next stop, you're gonna see on your left-hand side what would be a native pasture. Well, Florida will look, a lot of you know what Florida will look like without being developed, but the ones that, for the new Floridians, they've never seen, take a look, it's completely different vegetation. So we compare the native vegetation versus the Bahia grass. In terms of carbon sequestration, Bahia grass is much more effective, twice more effective at sequestering carbon. Because of the photosynthetic capacity is so much greater than some of the native species. The native pastures are dominated by C3 species, which are not very effective. I mean, the balance is still, I mean, even the native pastures, they still sequester a lot of carbon, but much less than a well-managed Bahia grass pasture. Any other questions? No? Okay, well, yes.
You indicated that your treatments had no effect really in that 2-year period. What would you expect to be a kind of a typical time frame where you would expect to see detectable effects on soil carbon if you're going to detect them? And what would your assessment of other studies that are longer term tell you about what you would expect if you impose these treatments over a longer period?
So Dr. Sullenberger's question was, my perception if we continue to study longer instead of doing short term, doing long term, what would be the expected direction, I guess. One of the things that it takes a lot of time for carbon to change in the soil is a microbial driven process. So the plants need to add carbon to the soil. Soil microbes are going to decompose that carbon. Part of the carbon is going to be emitted back to the atmosphere as CO2, and part will become part of organic matter. So that is a very simplified explanation of how organic material becomes part of the organic matter. But the reality is it takes years, and it's very difficult to monitor. So when a consultant from a carbon trading company comes here to Florida and say that they want to do something and see results in 2 or 3 years, I think this is quite unrealistic. So we're not surprised that in a 2-year time frame we didn't see. In fact, we would be surprised if we saw any difference. But it's just to show that the short-term change is very difficult to occur, unless if you have something extreme. Dr. Sullenberg and I did something extreme a few years ago with one of your students playing with stocking rate. And we were able to detect some changes in soil carbon in a very specific fraction. So as a indicative of what would happen in the long term. Instead of depleting soil carbon and doing that for 10 years, we looked at some of the fractions that are more specific. But in terms of commercial range, implementing a management practice and expecting that if I come back next year, take a soil sample like I normally do, I'll be able to see differences. I think this is quite unrealistic because it takes time and it's a very difficult, carbon sequestration is a very difficult process to measure in the field. So I don't have a time, 5 years, 10 years, it could, depending on what exactly you are doing, but it could be a very long time to be able to detect those changes. So for instance, the areas that we converted the native to Bahia grass pastures, they've been converted for almost 30 years. That's easy to see the difference. There's twice as much soil carbon in the Bahia grass pasture compared to the native, but this is being after 30 years of conversion. So imagine if I do something here now and expecting a few years to see a response, I think this is not going to happen. Any other questions? And I think I forgot to mention this study has been funded by the Beef Cattle Enhancement Board funds. I was a little reluctant to propose this because it was something that we knew that was not going to work. But sometimes science is about showing, because one thing is me telling it doesn't work. The other one is having a very strict protocol to measure things and reporting. So yeah, we can, I think we've said many times this in field days, we can afford to fail, but beef cattle producers cannot. So if they're investing on an amendment or something, they want to see a return. And so hopefully this information will be helpful to determine whether they want to be involved in that carbon trading market. Thank you. Thank you, Julian.